Okay, good day, sir. Good day, sir. My name is called Jasmine, and now I will present the program execution. Before that, this is our task distribution. Now I will run the code. Okay, so the first output will be the program will prompt the user to enter the number of time quantum they want to test out. So let's say you want to test out 12 time quantum. Then the program will one by one prompt the user to enter the time quantum. So we start from 5. Okay, after we input all the time quantum, the program it will calculate all the metrics, and together it will form from the matrix value it will form the chart directly. So this is the output. The output will show two tables. The first table it will show the arrival time for each job, the burst time, the number of interruption, and then the second one is the time quantum together with the average waiting time, average turnaround time for for each uh, for each job. Now we will present about the content of the table. Of my mic.
Okay, yes. Now you can see from the slide, it's arrival time, burst time, and interruption, input output interruption. So just now from the course code, he prompted for that the queue shows the slide is from 0 to 19, and it will show that every job arrival time, burst time, and input output interruptions. So for the next slide, it's also the same. It's a continuous of job 20 to F21 to job 30. Also the same as the previous day is continuous as arrival time, burst time, into inbound for interruption. So as for next slide is the average time for waiting time and the turnaround time after they calculated the burst time, arrival time, and the interruption. It will show that each time quantum, just like equality key in the 12 time quantum, which is 5, 10, 11, 15, 20, 25, until 60. It, the code, the coding automatically, the system automatically calculate all the average time for each average waiting time and average turnaround time for each time quantums.
Okay, here is the round robin scheduling function. This function takes a list of jobs, their arrival time, burst times, and a time quantum as input. It calculates waiting and turnaround times for each job using a time-sharing technique. The algorithm iterates over the jobs in a loop, allocating the time quantum to each job with remaining burst time until all jobs are completed. If a job's burst time is less than the time quantum, it finishes in the current iteration and its waiting time is updated. The loop exits once all jobs are processed, ensuring fair CPU time distribution among jobs in a cyclic manner.
Last but not least, this will be the graph comparison for between the average time and time quantum. The blue line represents the average time for the turnaround time, while the red one represents the average for the waiting time, and the green line is the optimal time for the time quantum, which is the value 35. Next slide. Basically, this is what I was talking about just now. The graph summary: blue line is the turnaround time, red line is waiting time, then the optimal quantum is at 35, which is the smallest one for the whole average. And then in conclusion, optimal quantum balance out the reduced waiting time and consistent task completion. Okay, thank you very much.